Frequency distribution and types of frequency distribution. That is what we are going to look at in this video. And please don't forget to subscribe and join my YouTube community. Introduction to frequency distribution. Frequency distribution is a way to organize data by showing how often each value occurs. So a frequency distribution is one of the data interpretation technique where the data are organized by showing how often each value occurs. So if you have a values or if you have numbers, so it is actually the work of the frequency distribution to show how much of that numbers appear. That is the meaning of frequency distribution. And it is very important in summarizing large data set for easier interpretation. So you use frequency distribution if you have a large data set for easier interpretation. So understanding frequency distribution is essential for identifying patterns and trends in data analysis. So this is how we have some of the frequency distribution. So frequency distribution, as we can see, is a tool or technique in statistics that help us to organize the data and also help us to reach meaningful conclusion. Like for example, I think if you can see from this figure, you see we have ages and their frequency. Let's say now we have a particular event, or maybe you have a group of people with their different date of birth. Let's say we have those that are born 1996, 1998, and 2001. So from that data set, if you look at it, you can see that 1996 has a frequency of 60. So what does that indicate? It means that there are 60 of those people that have in 1996 individuals, indicating that 1996 occurs 60 times. And if you can see clearly for the 1998, it has a frequency of 50. That indicates that 1998 appears 50 times. And we have different ways that we can actually generate a frequency distribution. If you look at the figure 1, the figure 2, the figure 3, and figure 4, they have different patterns, but they are all trying to provide the same information. So you can provide information about frequency distribution using different figures. You can use histogram, you can use bar chart, you can use line graph to show a data for frequency distribution. So this is the different figures that are trying to show how you can demonstrate or interpret frequency distribution using different charts. So what are the purpose of frequency distribution? The purpose of frequency distribution, it simplifies complex data set into a manageable form. So sometimes you can have a complex data set that you cannot even understand it and interpret it. But it is actually the work of the frequency distribution to simplify the data set or the complex data set into a manageable form that can be easily interpreted. And it provides a clear virtual presentation of data distribution, and that is what I shown from the previous figures. From the previous figures, you can see that you can present a clear virtual presentation of the data distribution using a histogram, the line graph, or bar chart. And it aids in making informed decisions based on data patterns. So from the data patterns, you can actually make an informed decision. So this is also another ways that you can have that you can represent or that can present a different frequency distribution. Like for example, we have normal distribution curve, we have Schwartz distribution curve, right and left one, you can have bimodal distribution curve, multimodal uniform distribution curve, exponential distribution curve, log normal distribution curve, and we also have power law distribution curve. So we can present the data in different way and in different patterns. So what are the components of the frequency distribution? The component of frequency distribution include data values or class intervals. Sometimes if we have a complex data set with a different range of number, so we can have a class intervals. Maybe you can say, okay, maybe you have a number from 1 to 9 numbers that occur, or you obtain a data that have a number between 1 to 9. You have 10 to 16. You have 20 to 17. Sorry, you have 20 to 30 or 20 to 29. So you can classify those numbers using a different class intervals where you can have, maybe you can say, okay, you want to have a number between 0 to 10. You see, it's a class interval. So you can go to the data and you can count those numbers that are between 1 to 10. Sorry, between 0 to 10. You can count them between 11 to 12. Then, so that is the frequency. So this is how the class intervals is. You can classify your numbers based on class intervals, and then you can now add the data. And you can see even the class intervals from the histogram here. We have 10 to 10, we have 0 to 10, we have 10 to 20, we have 20 to 30, we have 30 to 40, and we have 40 to 50. So these are the class intervals. So sometimes, ladies and gentlemen, you'll be given a raw data, and it is your work to look at the data and provide a class intervals so that you can easily present the data. And then in addition, another component of frequency distribution is the frequencies. So what are the frequencies? Frequencies indicate how many times each data point or class interval occurs. So that is the frequency. That is to count how many times a particular data or a particular class intervals occurs. Like for example, from 0 to 10, we have 4 frequency. So it means that the class intervals between 0 to 4 occur 4 times. Like for example, here we can have a data like this. So we can create a frequency tables from here. So you have a data from 1, 5, 3, 1, 2, 3, 4, 5. So all this is actually a data set. So you can decide to say, okay, you see this is the data set from here to here. So from this data set, you can decide to say, okay, you want to know the number of the frequencies of this data. So the first thing that you are going to do, you can now decide to say, okay, so you have the numbers. So 1. So you want to know how many times 1 occur from the data set. Then you go to the data and you calculate how many 1 as a point, as a data point. So you have 1, 2, 3, 4. You have, so if you can see from here, you have 4. That we have 4, 1. So you have 4 of them. So how do you do it? You use a tally mark. If you count, okay, you have 1, you use a tally. 1, 2, 3, 4. So that is why here you have 4. And you indicate the number. So here is the number. That is the frequency. So this is a frequency choosing tally. So you use a tally to calculate the numbers. And then you have 2. So how many 2 do we have in this data set? We have 1 here. We have 2. We have 3. We have 4. We have 5. So we use tally. 1, 2, 3, 4, 5. So that is why we have 5 here. So we have 5 frequency, meaning that 2 occurs 4 times. So this is how to generate a frequency table. So sometimes Cumulative frequencies are included to show a totals of to a certain point. So we also use a frequency tables to show the totals of to a certain point. So please, ladies and gentlemen, as we are doing the class, we are going to look at each and every of this, how to get the class intervals, how to get the frequency. So this is actually a general a general introduction of frequency distribution. So what are the types of frequency distribution? So there are primarily two main types of frequency distribution. We have on-group and we have grouped frequency distribution. And sometimes if you can check other sources, apart from group and on-group, you will also see categorical frequency. So categorical frequency distribution is used when the data is nominal. So when you have a nominal or ordinal data, you can use categorical frequency. And then for a group frequency distribution is used when the range is large. If you have the range of numbers, they are large and the classes of the several units in which are needed. And then for the on-group data is used for numerical data. So for both group and the on-group data, they are used when you have numerical data. But for the group data is usually used when you have a large range. While for the on-group data, it is used when the range of the data is small. So this is the most important thing between group and the on-group data. So for the group data, it applies when the data is large. And for the on-group data, is applied when the range of the data is small. And both the group and the on-group data is applied in the numerical data. While for a categorical frequency is applied when the data is nominal or ordinal. That is when the data is categorized into nominal and ordinal. So that is when we use categorical frequency. So each type is used based on the nature and the size of the data set. So each of these types of each of these frequency distribution depend on the nature as well as the size of the data set. So choosing the correct type helps in accurate data interpretation. So that is why you have to be very careful when you are going to use this frequency distribution, because you need to know when you are going to apply group and when you are going to apply on group data. So as we are doing the class, actually, we are going to look at each and every one of them. So don't forget, for the group data is when you have the range of the data is very high. So now let's look at the on-group data more closely. So the on-group frequency distribution, it lists individual data point along with their frequencies. So in the case of on-group data, you will have a data set. So from that data set, you may be given a raw data. And from that raw data, you can generate a frequency table. So that is how it usually appears. It lists the individual data points along with their frequency. And it is suitable for small or discrete data set. So when you have small or discrete data set, that is when you apply an on-group frequency distribution. And it provides a precise count for each specific value in the data set. So you see, as we can see, on-group data, ladies and gentlemen, it applies when the range of the data is relatively small. And usually, the range is taken between the highest value to the lowest value. So single data value for each class, there is a single data value for each class. steps similar to categorical distribution. So the first thing to do, make a table. And each unique data value is a class. Then you can use a tally frequency as I did previously. You can take a percent or relative frequency. And how to get the relative frequency is equals to the number of each value divided by the total number of values. So as we are doing actually the classes from beginning, we'll be able to do all these things. So let me actually look at some examples, ladies and gentlemen, here. You see here, suppose you have now you have. So as we can see, this is an example. Suppose we have the following data set representing the number of feet owned by 15 people. So you can look at the number. Each can serve as a data point. So we have 1 as a data point, we have 2, we have 3, we have 4, and we have 5. So from here, we can count how many 1 we have in this data set. So as we can see, we have 1 here, we have 2, we have 3, we have 4. So that's why we have 4 frequency here. Then 2 as a data point, we have 1, 2, 3, 4, 5. So that is how we have this. And then 3 as a data point, we have 1, 2, 3. That is why we have this 3. Then 4, we have 1, 2. That is why we have this. Then 5, how many? It's only 1. So that is why we have this. So ladies and gentlemen, this is how to calculate frequency distribution for on-group data. Please don't forget to subscribe and join to my YouTube community. This is very short and concise.